logical shifts, and you need to understand how to perform a logical shift left and right, and also how it has a drawback when applied to negative numbers, which we'll take a look at. Okay, so let's do some examples. 264, 128, so hopefully you're really familiar with that now. So the purpose of a logical shift left or right is to perform multiplication or division. So let's take an example where we have the number 40. If we were to divide that by 2, hopefully we can work out that we would get 20. So our result would be 0, 0, 0, 1, 0, 1, 0, 0. Now, if you can see that the binary number's nearly identical, it's just that the bits have been transposed one place to the right. And how we do that is we start off by performing the logical shift right by shifting in a 0 to the number, and then all of the other places shift one place down, staying in the same order until we get to the last one, which is disregarded, to give us the result. So let's stand and we'll check that the theory is correct. 1, 2, 4, 8, 16, 32, 64, 128. So if we take a random number and we'll work out what it is at the end, and we shift in a 0, move them down one position, taking our time not to make any silly mistakes. So when that number has been logically shifted to the right, it's going to divide by 2. So our final answer works out at 35, which should mean that the original was 70. And if we add up those positions, 64 plus 4 gives us 68, plus 2 indeed does give us the 70. If we look then at logical shifts left, those are going to perform multiplication. So let's start off with our random example here, 16, 0, 0, 1, 1, which is 19. If we were to double 19, we would hopefully get the result 38. So if we plan out what the result should be at the bottom here, 0, 0, 1, 6 more, 0, 1, 1, 0 is the result we're hoping to achieve. So if we apply the same logic as the logical shift right, except we'd kind of do the opposite, where we put in a 0 at the least significant bit and shift all the places 1 to the left, taking our time to make sure we make no mistakes. And we do shift out this last piece, but we obviously disregard it because we're dealing in bytes. And if you compare the results of the logical shift left with our original answer, you'll see that it matches up. Now it does have some draw in that if we were to shift negative numbers, it just wouldn't work for all occurrences. And the other problem we will have is when we try to take numbers like this. So we've got 33, that if we divide it by 2, we should end up with 16.5. So if we perform the shift correctly, we move in a 0 to the front position, move the rest all down, and then we disregard this least significant bit, and hopefully your math skills allow you to realise that this number is actually 16 when we were looking for the result 16.5. Now there are other representations that would allow us to store that decimal number, and when you learn about those and do some extra reading, you'll realise that there are ways to store that number. So logical shifts are used only on positive numbers to perform division and multiplication by 2. And again, practice these as much as possible and make sure you can explain how to carry out the process.